The recording is starting now. All right. And in the meantime, let me turn off my devices and pause. And there again, pause. Then let me turn off my Google Hangout. All right. I don't see Google Hangout. All right. Great. So, how have you been? I mean, how is the assignment coming up? We have been evaluating your assignment, and so some of you have done really great, and feel free to become active on our forum. Okay, and that way that'll give you more, more exposure to the questions. All right. All right. So before we start, do you have any questions for me? So, okay. So, how many of you understand what is zookeeper? Okay. So let me see if you understand it. That will help us uh, taking the session further. All right. So, before I start, what is zookeeper? Anyone? Okay. Vikas says it's a coordination service. Anybody else? Okay. Okay. All right. Okay. What is SVC? All right. Great. Okay. Great. So I think we all are on the same page. So this diagram will help us redefine what is the use of it. It's basically a central kind of a database. It's kind of a central file system. Okay. And okay, just give me a second, Aruna. Let me, yeah. So it's kind of a central file system whereby you can, so it's a central file system whereby you can store data. Now, your question would be, why Zookeeper, right? And and we'll also quickly recap on why not Zookeeper. Okay, so why Zookeeper? As in when there is humongous velocity, okay, humongous velocity, but volume is small, then Zookeeper is brilliant. Okay, so whenever there are lots of users who want a coordination, a central database system which doesn't go down, then you use Zookeeper. Okay, we could have used database. Okay, but database would suffer from availability. Okay, So Zookeeper is heavily available and consistent, and as well as partition tolerant. Okay. All right. Now you might argue that how can that be possible, all of these three? The reason is that it provides a very small storage. So in a sort of way, it is. Yes, the login has recording is going on. So availability is basically consistency is something which gets hurt a bit, but it is eventually consistent. Okay, but heavily available and is heavily partition tolerant. Okay, now so basically when you have lot of users trying to read and write the data, then Zookeeper just is a great solution. Okay, and it provides you those constructs which help you in coordination. Okay, so that's Zookeeper. When not to use Zookeeper. Okay, when not to use Zookeeper. Okay, first, when your existing DB is sufficient. Second is when your data is huge. Okay, when your data storage requirement is huge. In these two circumstances, we do not use Zookeeper. Third, okay, so if your existing database is sufficient for handling the load, you can use the database for coordination. Okay, you can add record there, and then others can retrieve that. And when you don't, when you, all right. What does term eventually consistent means? Eventually consistent means that if we wrote data, finally after a while things will be consistent, although they will not be immediately consistent. If you remember our cap theorem diagram, which we discussed last to last session, where we were writing data into one machine while we were reading from other machines. So it takes time for data to travel through from one machine to another, from the writer to the reader, because writing is happening on one machine and reading is happening from another machine. Till the time the change propagates from the writer to all other reader machines, it will take some time. Okay, so today's so Zookeeper is heavily available, eventually consistent, and partition tolerant. Okay, so in case some of the machines go down, Zookeeper will keep running. In case there is a huge load, it will be able to handle that. Huge number of requests, not huge data. The only catch in the whole game is the Zookeeper is suitable only if you are trying to store few KBs or few MBs of data. If your requirement is above that, then probably you are not, probably Zookeeper is not your solution. Okay. Okay, so HBase is not eventually consistent. HBase is actually uh, immediately consistent, and HBase is actually the diagram is actually wrong. If you see that diagram, I think I'll modify that diagram. HBase is not eventually consistent. Because if you remember, we had master, which means everybody is coming to master first, and then they're going to individual region servers, right? And therefore master is the bottleneck, and therefore HBase is uh, out of CAP, A is not there, only it's C and P. That's what we discussed yesterday. All right, I missed a couple of questions. So Aruna's question, there was one more Aruna's question. I'll pick that up now. Okay, so it would only support apps which do not count on data being, no, it it is good. It is actually good in the sense that, so another question is, if your application requires huge consistency, then you should not use Zookeeper. Partly the statement is correct. Okay. And the way Zookeeper ensures consistency, I'll describe to you that way. Okay. So Zookeeper tries to have a consistency in a different manner, that the writer will try to give the confirmation to the reader, to the client. So there is a machine in which you are trying to write the data, right? Zookeeper has got A, B, C machines. I'll just draw that. I think that will help you. So let's say, so in Zookeeper, you have a machine called master. Sorry, this we call leader. Okay. And there are these followers. Okay. Follower one, or we just mark them F1, F2, and F3. Okay. So all the writer requests come to it. Okay. So, and all the reader requests go from these. When people are trying to read the data, they get redirected automatically to F1, F2, F3. Okay. And internally, it will basically transmit data from leader to the followers. So this is client one, this is client two who is trying to write the data, this is client three. All right, so in this diagram, you can see clearly that the data is flowing from leader to all the followers. So these are the machines. These are all part of this whole thing is a part of Zookeeper. Okay, this is all a part of Zookeeper, and users are trying to read from uh, these machines, but writing is happening on the leader part. Okay, writing is happening on the leader part. Now, the question is that in case, so what happens is when the user, say client is writing, leader will not confirm to the client that I have written to your data unless majority has accepted the change, meaning out of three machines, two machines have done the confirmation that hey, we have written your data, we have saved your data. All right. So yes. So in a way, it is partly consistent in the sense that say we when C2 was trying to write the data, it it wrote to this one, it wrote to this one, it wrote to this one, and then gave the confirmation to the client. All right. And and but the data did not get written into F1. Now client comes in and inquires here, the C2 C1 will get the older data, right? So I will describe things as we go ahead. I think I am jumping ahead. All right. So it is sort of partially consistent. All right. Yes, Aruna, can you go ahead with your H-based question now? All right. Was I able to answer, Aruna? Okay. All right. So, okay. So a simple scenario what we gave was this web crawling corpus. And if you have a use some other example in mind which you can correlate more, I can give that example. Also, there was a question in HBase. If you go to HBase subjective, you will see a question on the website. All right. And I think I have not mentioned that to you. All right. So let me just put my phone on charging. All right. So see the what data to capture is your business requirement, and and I'll just have to first so this one if you have a look at it. So if you have to design a simple Gmail like email storage and you have to store the data in HBase, what will be the tables? What will be the row key column family columns under each family of each tables? So that was the question, and probably this is what you are looking for, right? So I think I need to take a better example. Imagine that you have to do a storage of a e-commerce website. Okay. So is anybody else interested in this question? So question is, uh, okay, build a storage. Okay. Uh, do you have any other example in mind which you can give? I think a better thing would be I'll tell you this. Okay. Uh, on a website, on a website, we track all the users' behavior, such as clicks. So when a user is visiting your website, you are tracking his behavior, such as clicks, mouse positions, such as current page user is visiting, time, and you are basically tracking the user. Okay, and you give a user session ID, and you also have time on what time is an event being created, and there is a mouse location. Okay, current page URL, and then we have mouse clicks, and a mouse click also includes drag, and then we have something called page scroll position, and we what else do we do? uh, Now, this is not a theoretical thing, it's a real thing. This is what is so in one of the projects which I was working at Amazon, what we were trying to do is we were trying to predict whether user is user will buy today or not. Okay, and we found a strong correlation between what users are reading and where is the cursor, meaning user will be moving the cursor, mouse cursor, along the way uh, his eyes are moving. Yes, so mouse click is the one which you are saying. So okay, so on what time user is doing what on what position of the page at, and what exactly is the user doing, this is what the scenario is. Now say we so at Amazon we were tracking this, and based on this information we were figuring out whether user will buy or not, and we were able to do it to a very large extent. We were able to predict that the user will buy today. Okay, now if you have to build such a storage which can be used, so which can be used by the user, so first thing would I would do is I would do is so there are two dimensions the things are going. First is for each user, for each session, I would call session, there are many events. Okay, so I would actually store it such as the row ID would be session ID. Okay, that's a unique key. All right, but this design will keep on changing as and when our requirements grow. And then column families will be something like pages. Okay, and so let's just design one thing at a time. So for a one user, I think a spreadsheet will be a better way. Yeah, row ID equals to row key. Just give me a second, I'll mute myself for a minute. All right, so coming back to the problem again. So we create the table with the name called, say, uh, click user data. All right, and from in this one, so we mark a column family and I'm going to merge these cells just to mark it as if it's a column family. And before this, yeah, this is my row key. This is my row key. Okay. And this is my column family, say, what do you call, pages. Okay. So as in when a user with a session ID, row key is my session ID here. So let's say a user with 123 session ID visited one page, say some URL slash X. Okay. So that becomes my column header. This becomes my column header. Okay. So I put this in my column. This is my column name under pages. I've created one column name called slash X. And under this, I'm putting that what the user has done here. Okay. Say, you can say clicks, on page X, user clicked the coordinates of clicks. I can say click at X comma Y and so on. Or we could say, we could also say that, so on page number Y, we are doing something else, and each event detail we can actually put in the cell itself. Clicked on this page, and at this time, and so on. Okay. So we could also say things like, um, clicks, and then we can say put the values here. Okay. Clicks on X, and similarly there'll be another, uh, uh, you know clicks called Y, and on each X and Y we are putting the details of here. So we could say user clicked at this time and this time. Okay. So we can keep on adding these columns, and so it's actually a very fluid design, and there is no right or wrong in this. Okay. The that other design could be that we put URL in a row as and when, yes, different column families. So click X is a column family, click Y is a column family. Okay. So this is one column family. This is another column family. So session, for each session ID, user clicked on this page on and Y was said this. Okay. So you can keep on adding these kind of things. And in URL, you can also put a timestamp, or you can basically put the timestamp when you are adding these values. So you know exactly on what time what is happening. All right. Yeah. Okay. So two questions here. One is Vikas is saying, All right, good, good. I'm getting great questions. Now, here, just let me go up, up. Yep. So here are a great set of questions. Let me address one at a time. And so first question is from Kalyan. Are here slash x and slash y part of the column family? So slash x is one column, slash y is another column. These are another URL. Okay. This is something like slash x slash y and so on. Okay. So maybe, yeah, here like this. Okay. So this session ID, this 123 session ID is what user is represented by. He clicked on 1 and 2 on this page. Okay, the x coordinate is this, y coordinate is this. I think a better thing would be to store them in the same one. It's a bad design actually. And so, okay, 1 comma 2. Okay, now coming to, yeah, so why I'm saying that design would change? I'm saying that design would change based on your requirement. Right now, we have not drilled down on what kind of requirement we have from this. And that is why my design might be absolutely wrong when it comes to your kind of data. Or in other words, I would like to confess that I've not thought through the way I would design this way. Okay, this kind of system, how exactly, what are the various things, so I might have to keep on changing the design in order to come up with a better one. Okay, so let's say a click happens, so I'm adding one column in clicks. Okay, on this page this click happened, then on this page another click happened. Ideally we should, yeah, so because if on the same page there are two clicks happening, that's not a great idea. Then we cannot add slash x again here. Therefore this design is not great design. So maybe we need a little bit more time to come up with a better design. So what all things we are trying to track? We are trying to track mouse locations. Okay, so for each session there are many events. Okay, and each event is user for each session there could be multiple URL. So a user is visiting multiple pages, and on multiple pages there are various events happening, right? On multiple pages there are various events happening, correct? And so what you need to do is you have a row ID. Okay, and the other design could be that on we could keep the row ID as the URL. Okay, coupled with the session ID. Okay, and then and the columns we could have with the name of various coordinates and I mean various events. Say maybe time here is, say, time. Okay, so time 1 click happened, time 2. Okay, and so on. Okay, so 1 comma 2, 2 comma 3, and so on. Okay, I think this design looks better. So I'm saying click has happened at 1 comma 2, and then at time 2 the mouse drag has happened at from 1 comma 2 location to 4 comma 5 location. At time 3 scroll down happened from scroll down by say 2 pages or 1 pages and so on. Okay, I think this looks a better design. Okay. So yeah, row key is a byte array. Okay. So you can actually put the full any object you want to put, whether it's a composite or yeah. All right. I think we are evolving our design really well. So now let me just do one more thing. I remove this. I do these things. Here we are saying drag, and again time 2 is one column here. Okay. At time 2. Okay. Now we could have another column family here. From here to here we could. Okay. So yeah. So let's call it scrolls. And under scroll we are having time 2, and we sorry, time 3. Yeah, time some other time. Okay. Now this looks a little better design. So what have I done here? Let me just try to fit everything into one screen. Okay. So it would look like something like slash x, and or maybe first session ID 123 followed by say double colon or something, whatever you plan to do, and then is the URL. Okay. In the same session, if there is another URL, then we could do these kind of things. All right. Yes. So instead of the only difference is you might argue here. Let me what what is it that I'm trying to do? Okay. So this looks like just one another design. Okay. And if we a little think through our requirements, we might come up with a better design as well. So what we are doing here is for each timestamp, the time one means maybe time in nanoseconds. So this user 123 session ID, that's what represents our user. This user is on this particular page, and he has done these clicks at this time, done drags from this to this, and scrolls from here to here. Okay. So that's what is, as and when the event is happening, we are adding columns into these three separate buckets. Okay. Now you might argue that why are we using time here when our each cell is going to be anyway versioned, right? Because the versioning has a limit, meaning we always configure that only 5 versions or 6 versions should be kept of each cell. But here, when the user is clicking again and again, there could be 1,000 events from a single user, right? If it's like say crawler, he might be visiting your website and there'll be thousands of page visits, and therefore our usual you know if we had a single column for all of these values, and in each cell we were having the various versions. Okay. So is this clear? Does it make sense to you? So we created 3 column family: clicks, drags, and scrolls. Okay. And now coming back to the row ID, now again, what how would you like to structure it? Okay, I would actually like to structure it other way around. Now we are not exploiting one property of row key, which is sorted row key, right? So a better idea would be to store it in this fashion. I'll tell you this here. First first the URL, okay, and then space, then the session ID. I am using space because space is not generally part of the URLs. Okay, so maybe say tab, so URL followed by the session ID. Now again same thing here. So the same user visits another URL, okay, like this. So does it make sense to you? Yes. So Lingley's question is same URL but different user, right? In those in those scenarios, it will be like this. So say same URL, different users. Now, why I have put it this way? Okay. Reason is that we are more interested in storing the behavior of multiple users towards a single URL. So basically, all the behavior related to a single URL, I want to keep it together. Okay. In case you are interested in keeping the the various users data, single users data together, you will choose the session ID before the URL. Okay. So this data will actually come here. This data will actually come here. Make sense to you? So Kalyan's question is all values can be kept under one column family. Right, right. So the problem with this is that if we were keeping, say, clicks, drag, and scrolls into single thing, then in each cell we had to mention that this data belongs to clicks, this data belongs to drags, and this data belongs to scrolls. Then we had to mention that in the cell. There was no, I mean, that's not a big deal. Okay. Now, the only thing which is bothering me as well is that do we need to keep this composite key? Is there any alternative solution right now? Okay. Do you think there is an alternative solution? So, in instead of keeping these composite keys as row key, can we do something else? Anyone? Yeah. Hmm. Concatenate them as this is concatenated. It's just that separator is a tab here. I put a tab as a separator. Okay. Hmm. So can we keep the URL as part of each column family? You mean clicks colon URL? The, okay, okay, okay. Mm-hmm, mm-hmm, mm-hmm. That's also a good idea. So, okay, let me understand what you're trying to say. Let's say one right here. Let's say you're saying the put a URL here and like this, right? That's what you're saying. Mm-hmm, mm-hmm. Okay, that can be something we can think about. Yeah, no, I think this will be here. Or what could we do is that, okay, okay, okay. So, yeah. So generally, there are few things we can take away from this kind of design. First, you always tend to keep everything in a single table. Okay. Ideally, had we been handling it in using relational databases, we would what we will do is we'll keep two tables or maybe three tables or four tables, right? And basically, the only dimension of change in normal RDBMS is adding rows. If there is some data is being changing, you design your database such that the rows gets added but columns do not change, right? Here, you columns are getting added as in when something is happening, as well as rows are getting added. All right. So as in when user is visiting a URL, uh, when a new user is coming in or visiting a URL, then these things are happening. So you visit a URL, we create a new row. If on the same URL you are doing multiple activities, we keep on adding columns into various column families. That's what is my design. Definitely, you can come up with a better design, all right, and we can discuss it. And in the matters of designs, there is no such thing called right or wrong. It all depends on how well it serves to our use case. Okay. So Aruna's question is, one table seems to suffice for this. Do we need to create more tables? So generally what happens is there are other tables in which we also record like this user ID means this username, this login, all of this information, their address, this, that. That also we can keep either in HBase or in other systems. Okay. But But the data which is changing fast or humongous, we tend to keep it in HBase and we try to avoid joins as much as we can. Okay. So, yeah. So, Aruna, Kalyan, and everyone, You also give me a better design. Think about this question and think about storing this data, and give me the design in terms of a similar diagram, or maybe a simple write up. That will be a great exercise. And let's also maybe if, whichever problem you like, this one or this subjective problem, try to think about the design, and you will definitely understand how I mean, in the meantime, you will actually understand how can you exploit the properties like row keys are ordered, column names are fixed, column families are fixed, but you can add columns as well as rows. Then you have various versions of each cells. All of that can you can put to use. Okay. And column name can have data, cell has data, row name has data, and this data can be JSON, XML, or any binary data. It could be like movie, it could be anything. So this data inside the columns, here we have written time one, here we have written this. All of this can be anything. Okay, so come up with the designs and it'll be a great exercise for all of us. All right, so this design is clear, okay to you, right? To me this looks okay, but there are a lot of improvement that I foresee, and we can do a lot of improvements over this design, because it's not it's still suboptimal. All right, Vikas. Great. So that was a good discussion. All right, essentially this tells me that you are paying attention. And yeah, great, great. All right, so carrying on. All right, so all of us are okay with Zookeeper, right? The why do we need it? And we also discussed something called our various kinds of nodes. Like there were persistent node, there were transient nodes, and there were the where is the definition? Ephemeral, we call it. Transient is ephemeral, and then there were sequential nodes. All right, great. Thank you, Kalyan. So, so we can do all kind of things like creating a node, deleting a node, updating a node, and creating a ephemeral node, creating sequential node, creating persistent node. So when we have to add data permanently, then you use persistent node. If you want to just put our attendance, a node that it will be alive as long as we are connected, then we create ephemeral node. If we want to generate a sequential number, then we use sequential node. All right. So these three paradigms actually solve three very different kind of problems. All right. And you never append data to the node. You always overwrite. You do not do partial addition substitution to each node. Instead, you replace the whole data at each node. All right. I think somebody was unmuted. All right. So now the other thing is that these APIs, since it's a heavy load system, so all the APIs, when you do all of these operations, what we just discussed, when you try to do this programmatically, all of these things can be done using your program in C, Java, Python, Perl, and REST interface. And everywhere for each work, there are two kinds of functions. Okay, this is like a next generation design, and all of us should take an inspiration from this. Whenever you're designing an API, you always design two kind of API, two kind of functions. One is asynchronous, other is synchronous. Synchronous means I asked you something, you said just hold on, I'm replying to you, so I wait there till you reply. Okay, asynchronous is that I asked you something and you said that, hey, can you just wait in the wait on the couch and I'll give you a call back when I have the answer for you. That is asynchronous. Okay, I will call back when it's required, which means so when the callback comes in, you have to give a callback function name the way we are providing here, saying when this function exists, please use this callback method to call me back. Okay, here it says that you will have to wait till the function exist finishes, and once exist finishes it will return some value called stat, and that you can utilize further. So these two programming paradigms are completely different, and they change the way programmers think. Okay, they change the way programmers think. The whole storyboarding becomes really different. And interestingly, every one of us, including myself, is able to easily work with synchronous calls. But working with the synchronous call requires a different mindset. It's like finish this once, and once you finish this, do something else. Let me do something else right now. Okay, so Kalyan's question again is, does it like a pseudo? No, it's not like a pseudo. I will try to explain again. So how should I describe? So there is a statement one and statement. Okay, so there is, we called a function one. Okay, and there is print hello. Okay, now if this function 1 is synchronous, okay, if the function 1 is synchronous, it will, unless and until function 1 finishes the work, print will not be printed. If it is asynchronous, if function 1 is asynchronous, it will go into the background doing something, and hello will be printed. Okay, so basically whenever you are executing an asynchronous function, it goes into the background. It starts doing things in the background, and while giving the control to the next statement. So that is asynchronous. Did it make sense? Any doubts now on asynchronous? All right, so the whole model, when you are designing say a website, and you say that once data gets loaded, do these things, when this thing gets done, do that thing, and so on. So that's completely different from our ordered way of doing things. In our ordered way of doing things is download the data, then do this, then do that. Okay, it's strictly sequential. Here we say that function one, and on finish do a call my function two. Okay, and inside function 2, the way we have defined our function 2 uh, uh, would be, function 2 would look like do something. Okay, and if function 2 is calling some other function 3, okay, then we might be passing another callback of function 4. Okay, so we are telling here that hey, once you are processing of function 1 is done, call function 2, and inside function 2 we might be having another function called to function 3, which is again asynchronous. Inside here we are saying that please do the job of function 3. Once that is done, call function 4. Okay, so that's the way lots of parallel processing is done, meaning we do not wait, we do not get blocked if it's taking time to read data from disk, we do something else. Okay, so that's where asynchronous calls come into play. All right. Similarly, Zookeeper, when you are creating a node, say you are creating a node and you want to get information that whenever a children is added to this node, please let us know. So you can create watches while creating a node, and these watches are triggered by the database, and they are only triggered once, meaning if you want to keep continuously getting update from a folder, so inside the watch trigger you have to in again put another watch saying create another watch and let me know once it happens again. That is the only way to get the frequent watches, basically getting the notification on each node, each desired node. All right. Now there are many kind of watch triggers. So the triggers of when you are say, so whenever, how do you put the watches? You put the watches whenever you do things like create node, do an ls as in check if the node exists, get the data, get the children. So all the watches of exist function will be triggered whenever the node, if this node has already been there, if the node gets deleted, then you get a notification. If the data gets updated, then you get notification. If the time you placed a watch, if the node did not exist, you will get a notification when the node gets created. It's like putting watchtowers everywhere, and keep an eye on your data, and this way you can actually build a really robust system of communication between one application and another. Those who are familiar with event buses, where when the user right clicks, then you show these things, when something happened, when an email comes up, show the notification. So all of that philosophy can be built using watch triggers. Okay. So, and the watch triggers are another reason why people use Zookeeper for their coordination work. All right. Now, as usual with any tool, since a Zookeeper instance, if you've installed in your organization, it is going to cater to all of our users. Okay. Like for example, if we let me try to log in. So here, okay. So is my screen clear? All right. So now you can see that these are most of these nodes are created by us, while there are some nodes like HBase unsecure. This node is being used by HBase, and inside this it's basically using a Zookeeper for the coordination. Okay, like who are my region servers. Okay, so you can see that under RS, these are the region servers: Hadoop 3, Hadoop 2, Hadoop 1, Hadoop 4. So these are my, most likely these are my ephemeral nodes. Okay. All right. So I think the way I get to do is, yeah. So this is one node. If we shut down Hadoop 3, this node will automatically disappear. Why? Because a Hadoop 3's reason server has created this ephemeral node, and as soon as we shut down this Hadoop 3, this folder will disappear. Okay. So it's not only us who is using Zookeeper. There are many other systems which are using Zookeeper. Okay. So Zookeeper itself is using its own service. Okay. So like for example, for quota management, it's using this. Okay. And there were some more example. Yeah, Templeton Hadoop was another example where where the jobs coordination for jobs coordination Hadoop is using Zookeeper. Okay, these are the various jobs, okay, which are running. All right. So what I'm trying to say is that in an organization there will be hundreds of users using Zookeeper for various kinds of work. Okay. And therefore, when there are many users, you need to have access control list so that you can have a clean control over who can do what. And whenever we are defining controlling access from various people for various applications, there has to be authentication and authorization. Can anybody tell me the difference? What is authentication and authorization? The difference between authentication and authorization? Yeah. Okay. Correct. Authentication is correct. All of you are correct. Great. Okay. So authentication means when we collect our card at the main security, they will mark that you are this and this. So it's like taking an identity card. Okay. Say I am Sandeep Giri and this is my card. Now this doesn't entitle me to do everything in an organization. Okay. That what all am I entitled to do, that will be defined by individual departments, and that will be defined by various my as the time progresses. Correct. So I will remain Sandeep Giri, but my roles will change, my permissions will change, my authorizations will change. Great. Great. So all of you have, yeah. So auth is ID card to enter building. Thank you, Aruna. And authorization is which floor can I access. Perfect. All of you are correct. And yes, great. So so in the similar fashion, Zookeeper provides you authentication based on digest. There are three kind of authentication which are possible, which means either the user can remember its login password, or you can use user can use Kerberos. Okay, meaning they using a single sign-on solution like Kerberos in Linux or Unix systems or Windows systems, they can just sign on once and the same identity can be used here. And third is the IP address that is good for these data centers, because the way our HBase was talking to our Zookeeper, in the same fashion there could be other services that would be talking to my Zookeeper. So in those cases we can have IP based access control. Now ACL is a combination of authentication scheme and set of permissions. Okay, authorization and authentication. All right. So basically, it provides you access control. You can have a look into more into how to configure Zookeeper. Getting into those administrative tasks will be actually in itself a big independent session. Okay. The more idea about this session is you should get an overall perspective about Zookeeper so that in a design you can take a call whether to use Zookeeper or not. Okay, and and you can do the basic task by yourself. So, all right. Now, coming to the architecture, there are a really interesting thing that is coming up. So, just like all other services, Zookeeper can run in two modes. One is standalone. Of course, in case of big data scenarios or any kind of distributed computing, standalone is useless. Standalone, if you are running standalone, a database is a better thing to do. Okay, standalone is great only for one thing, that is testing, right? While the replicated one is the one which is important. Replicated means it is distributed. So there are multiple machines which are running Zookeeper. When we said Zookeeper client, it internally connected to multiple machine. And when we are saying LS, it's talking to multiple machines and giving you the results. And how is it doing that? That's what we will talk about. Okay. So interestingly, so far all of the tools we have studied, starting with SDFS, Yarn, uh, and then HBase, Hive, Pig, all of, I mean, Hive, Pig are just clients, so let's not talk about those. So HBase, HDFS, and Yarn, in all of those, there was master and slaves. And master was selected by us. And that is the difference in Zookeeper. Okay? Zookeeper In Zookeeper, there is a cluster of machines. We entitle them saying, you are an ensemble of machines. Okay, we call them ensemble. And and this ensemble will keep on running as long as more than 50% machines are alive. If the 50% are dead, then you will have to manually intervene and then make it run again. All right. So the way it happens is when you have say 10 machines you have dedicated for Zookeeper. Okay, you are expecting a huge load, so you dedicated 10 machines for Zookeeper, or you are running Zookeeper on the same machines as data node or name node. That's irrelevant. So you just like, because when we say we dedicated 10 machines means we installed Zookeeper on each of these 10 machines. Now, the first thing that would happen when you turn on the ensemble or when you are installing these services, the first thing that would happen is the leader selection. Leader selection means leader selection means who will be the master? Who will be the master? Okay, and what is the role of a master? So the ensemble, when it's up and running, will have something called a leader or master, meaning the leader will accept all the right requests. If a user is trying to create a node or delete a node or update a node, the request will go to the leader. Okay, why? Because we do not want multiple nodes to write the data. If multiple nodes start writing the data will not get consistent even eventually. Okay, if there are two nodes parallelly deleting or updating the same node, two computers deleting or updating the same persistent node inside Zookeeper, what will happen to our data, right? Therefore, there has to be a singular writer. There has to be only one writer to the data. Okay, so the leader selection phase is very important. So this is a distinguished member, and it could be any machine in the ensemble. Ensemble decides who will be the leader. Okay, so once the leader is selected, and the way leaders get selected, all these machines in the ensemble, they vote for one machine automatically. This voting happens, and the voting is based on which machine is responding to the pings really well. So each machine is in ensemble gives their order of preference, And out of this order of preference, a reconciliation happened during election, and and ensemble decides that this machine is really performing well, and therefore let's make that machine as leader. Okay, now the moment the leader comes to the leader is elected, all the ensemble knows that this machine is a leader and these are the followers. So each machine knows each other. Okay, now the moment the leader election has happened, they all synchronize their state with the leader, and now the writing happens. Now, in case afterwards the leader steps down or leader fails, the re-election would happen. If the leader failed to perform something, leader will step down automatically or will be forced to step down. Okay, and re-election will be announced, and all these machines will again start participating in the leader election. Please note that this is the same mechanism followed in systems like MongoDB, where high availability is the bigger concern, and this is called Paxos algorithm of leader election. There's a researcher from Microsoft who has done really marvelous job. He's a mathematician who has done a really marvelous job in defining this algorithm. Okay, so we will go into the details. It's not about only Zookeeper. It's a very important aspect when it comes to big data or distributed computing. Okay, yes. Now, so it's actually quite interesting. We'll go into more details as we go further. So all of these machines come up and they do the election. And if you have read about a book from Michael Crichton called Prey, in which there are these individual in nano robots which are communicating amongst themselves, and the study which Michael Crichton did was exactly similar to what it is, okay, in the leader election here. All right, so it's actually a little bit sci-fi. So whenever our clients to so Zookeeper clients, when they connect to the ensemble, they gather all the IP addresses of all the machines. Okay, the client knows all the IP addresses of all the Zookeeper nodes, and they also know that who is our current writer in the game. So the client, basically, whenever we are writing, the client goes to the Zookeeper ensemble and says, hey, I want to write, and I was told that this guy is the leader. So ensemble might that guy might say that, hey, I'm not leader anymore, that other guy is a leader, you go to him and write there. So this keeps on happening invisibly from the user's eyes. Okay, and so at the end of it, all the write requests, whenever we are trying to write, the requests are forwarded to the leader, and leader broadcasts the update to all the followers, and when a majority have persisted the change, the leader commits the update. What does it mean by majority? Meaning, out of 50 nodes, if 26 nodes, majority means one more than 25. If the moment, because this leader has to propagate this change. Okay, this leader has to propagate this change, and in case the machine on which it has propagated the change, that machine fails, the data will be lost. Okay, now therefore it propagates the change to majority of the nodes. Out of 50 members in ensemble, the moment it is able to write to 26 members, it will confirm to the user, hey, your data has been committed. All right, and therefore now you can understand that since this writing will take time, and it will take parallel time, right? if one machine is if there is a slowest machine which takes 2 seconds to write this data, therefore the overall turnaround time will be 2 seconds. Okay, because all of this writing is happening parallelly. Now now if the data is really huge, the client might have to wait really long. So the overall performance of the ensemble is equal to the slowest member while writing, right? While writing, the overall performance is equal to the slowest member. Now, when a majority have persisted the change, leader commits the change and clients get the success response. The protocol for achieving consensus is atomic. Atomic like two-phase commit. So protocol of achieving consensus means when you are when you are saying that, hey, I have written the data, or this guy becomes the leader. So all of this is heavily consistent. It's heavily atomic. Atomic means either happens or doesn't happen. There is no such thing called partial writing of the data. In case the data was partially written and the the machine failed, okay, so immediately the whole data will be reverted. Okay, therefore writing to each node is atomic, whether the node gets updated or the node does not get updated, but there is no such thing called uh, partial updation of the record of the node. Okay, and also the important part with this zookeeper is the data is written to the disk first and then the response is given. Unlike, this is the difference from MongoDB. In MongoDB, the data is written to the memory first, memory pipe, and then it goes to the disk. Here, in favor of being persistent, it says that since I commit to the persistent, I say that the storage is persistent, therefore I'll first write to the disk, then will load into the memory. So that is the difference. Now, so the plan is clear to all, right? So there's a leader selection, and then any questions here? Whatever we have discussed just now. All right. This diagram will make it little more clear. So this is ensemble. There are three machines, and these three machines have elected one node as leader. And whenever clients are coming to read the data, followers will respond as well as leader will respond. While if the client has come to write the data, like this client, the the request gets redirected to the leader. Okay? No questions? So you do not elect the leader. Leader is elected by itself. Okay? We just set up ensemble and that's all. In this exercise, we'll not be doing this in this as part of this course. Okay? But it is a general idea in heavily distributed or highly available systems. So Zookeeper is probably the most highly available system designed. All right. So here you'll not be doing much of setup. Any other question? So Kalyan's question is, if we add a new node, election will happen again? No. Okay. Election will not happen again, and this strategy would vary between multiple systems. In case of Zookeeper, it won't happen. All right. So if there is already a leader, that leader will remain as such. This new node will synchronize its state from the leader, and it will also have that data replicated. Okay. Now, since the data gets replicated on all machines, right? Therefore, Zookeeper is not great when it comes to storing big data, but it is great when it comes to availability, and it is great when it comes to partition tolerance. Meaning, if machines keeps on going down frequently, then this Zookeeper is great. And there are so many requests coming in parallelly, then Zookeeper is also doing a pretty good job. With respect to consistency, it tries to give you a decent amount of consistency, but still it will not be able to give you a guarantee of the consistency immediately, because it only writes to the 50%, more than 50% of the records, which is little above 50%, and therefore more than 50% will still some requests will still be reading the older data by the time the eventually consistency comes into play. All right, now important part here is, in case, so Kalyan talked about asked about what happens when we add a new node. Now question is, what happens in case we remove a node? Okay, we have three node, and the moment we remove, say, leader, re-election will happen definitely. Okay, but in case we remove another follower, the re-election will not happen. So, and in case two nodes go down, follower and follower, which means the re-election will happen again. Why? Because ensemble is happy as long as more than 50% are available. Okay, leader is happy as long as more than 50% of the nodes are available. The moment m- more than the moment 50% or the moment out of 100, if 50%, 50 node go down, leader will resign. There will be no leader, and the whole ensemble will become read only. The whole ensemble will become read only. This is very important aspect. So if you have, say, look at this. This is a better idea. So we have an ensemble of three computers, A, B, and C. Now leader went down. What would happen? Okay, anybody? If we have three nodes A, B, and C with A as leader and A dies, will someone will become no leader? I'm talking about zookeeper election. Yes. So either B or C will become the leader. Either B or C will become the leader. Okay. So Vikas, I'll answer that question after a while. All right. Make sense to you? Now the next question. I was talking about ensemble tolerates the 50% majority basically. Okay. Now question here is, if B also dies, will C become the leader? Will C remain the leader? Anyone? So earlier A machine was died, and therefore C became the leader. Now B is B has also died. Will C remain the leader? Anybody else? Aruna says no. And do you think the reason behind it? Because theoretically, yes, we lost 50%, as in up to 2, 2 is more than 50% of 3, right? And the moment we lost 2, which means 1 is less than 50% of 3. 50% of 3 is 1.5 and 1 is less than that. Therefore there cannot be a leader. Okay, so on the prima facie it would look really really stupid that we have at least one computer, right? Out of 3 computers we have one computer running, and still zookeeper is behaving stupidly and is not solving our purpose, right? When we have no leader, that means when we have no leader that means it will not accept any write request. If you look at it uh, from normal architecture perspective, it is stupid, right? But we'll come to the exact reason why it behaves like that. Okay, so say if you have 20 nodes, okay, and out of that 10 nodes are down, the zookeeper cluster will be read only, meaning meaning no leader. Okay, so if you look at it, it looks stupid that we have 10 computers and still the whole thing is uh, you know still the zookeeper is not giving us the output, right? Or can anybody explain why do we require majority, in other words? Anybody? Okay, Aruna says because of the way leader writes only to 50%. Good, good. Okay. And again, the same question, why is it that necessary to write to 50%? And why 50%? Why not 30%? Why not 40%? Why not 45%? All right? Okay. Okay. So actually the reason why it has to write to the majority is because of this reason, that because of 50% ensemble reason. Okay? Is the other way around. All right? And yes, yes. Okay, so now let's have a look at this. I think it took me some time to understand this idea. Why is it 50%? Okay, it took me some time to understand, and I understood it when I was earlier. I was working on MongoDB. Okay, so I found it very very awkward, and everywhere I found is that they say that it's 50%, 50%, and nobody gives a good reason why is it so. So let's have a look at this. Imagine that we had two data centers. Okay, data center 1 and data center 2. Okay, we have six nodes, and let's say we designed a system which doesn't care about which doesn't care about how many nodes are alive. Okay, and all they do is based on the votes available at hand. Okay, it just decides whosoever is getting the maximum. So I'm just talking about this imaginary system. Now what would happen is if this cord between this data center is cut, Yes, anybody? What will happen if this cord is disconnected? Okay, or you can say that in the first data center there was one leader. Okay, and and then cord got disconnected. What will happen? Actually, election will happen again, right? And let's say that we did not care about 50% majority. So here in data center 1, the leader might remain leader, and in the data center 2, we might get another leader here. There'll be another leader. Okay, so, and let's say D became leader. Okay, now see the thing. So the cord got disconnected between data center 1 and data center 2. And if there was no majority required, so E and F voted for new leader, and here the leader remained the way. So if 50% majority was not required, will become two leaders. Okay, which means any request coming from the client might go to A or might go to D. Okay, some clients are writing to A, some clients are writing to D, and effectively the data becomes absolutely inconsistent. Okay, and the partition has happened. You got the idea? All right, that is the reason why we require majority. All right, so that there are never two leaders, because because there can be only one bigger than 50% size of cake. Okay, if you cut the cake such that there is one piece which is bigger than 50%, that means there is no other a bigger piece than that, right? There can be only the one which is bigger than 50% can be only one, and therefore in any network there will be only one leader, no matter how many nodes are dead. Okay, makes sense to you, right? Suppose we have 10. Now I'm coming to that question exactly. In an ensemble of 10 nodes, how many nodes shutdown can it tolerate? Correct. All right. So Kalyan, was that your question? I intercepted. Okay, go ahead. All right. Now this is a common thing which we are doing. We have already talked about this. Out of 10 nodes, 6 are in data center 1 and remaining 4 are in data center 2. Okay? So, yeah. So what will happen is, yeah. So what he's saying, let's say let me just draw it. Okay, so you have one data center this side, another data center this side. This side there are six nodes, and this side there are four nodes. Okay, now so what he's saying that the connection between these two got disconnected. Okay, now what will happen? So here the leader will be this side. Okay, if the leader was here, let's say the leader was here, he will step down, he'll basically step down. Okay, and the leader will be on this side because he will get the majority. And all the machine this side, this will become the read only cluster. These all machines will become read only, and after a while they will shut down, because in case of zookeeper, it will, if the data remains stale for above certain time, it assumes that you are not using it. Okay, and therefore all nodes shut down. Like for example, in our system, yesterday when we turned it on, we noticed that our region servers were dead. Reason was that after a while, maybe few hours, it detects that, it assumes that we are not uh, getting the data. Okay, and there is no majority, so it automatically shuts down. So first they will all become read only in the second data center, and then they will shut down after a while. They'll assume that leader is somewhere else, and we are not, our data is anyway stale, so there's no point in serving this stale data. All right, does that answer your question, Kalyan? Now the moment, if there are, say, let me just draw, one, two, three, four, five, six, right? And in case one of them goes down, let's say this one went down, and okay, then this leader will also resign. There will be no leader at all. All right. All right, so we have already discussed that in case there are so many clients and there are so many servers, and these clients want to find out which server to connect to, they can ask Zookeeper instead of directly maintaining the list of all the servers. Instead of all of these clients trying to manage the list of servers, they can use Zookeeper instead. Okay, if all these machines keep on pinging to all these servers to keep a track of who is up and who is down, then it is going to be very very inefficient. Therefore, servers inform their status to Zookeeper, and the clients discover the status about servers from Zookeeper. Okay, so Zookeeper acts like a coordination service. The other use case, so like for example here, s- so this is basically what we have already demonstrated yesterday. So initially there is this zookeeper. Okay, this rectangle represents the zookeeper, and so first the servers will come up as soon as a server is turned on. S- so for zookeeper, server as well as the clients are all the clients. Eh, okay, whether it's h-based server or h-based region server, h-based master, they are all the clients of the zookeeper. Okay, so I missed one question from uh, Vikas, I think. Because I'm not able to find your question. Could you help me? Okay. So let me answer Vikas's question. How does Zookeeper integrate with HDFS or MapReduce? So generally you don't. Okay. So Zookeeper does not store its data at HDFS or MapReduce. Okay. And you don't have to, because we are not going to deal with humongous data in Zookeeper. But HDFS and MapReduce use Zookeeper for their coordination requirement. For example, to track the data nodes, name node uses the Zookeeper. Similarly, in order to keep a track of who is name node and who is secondary name node, data nodes use Zookeeper. So Zookeeper acts like a coordination service between name node and data nodes. Similarly, between the HBase master and region servers. Similarly, between the task tracker and node manager and resource manager. All right, does that answer your question, Vikas? And I think that answers Amish's question also. So Zookeeper does not depend on HDFS or Hadoop, while Hadoop depends on Zookeeper. So the way developers use Zookeeper is via this kind of API provided by Zookeeper. As I was talking about the two kind of API, okay. So there is an API in Java, C, C++, Perl, Python, PHP. You can have take a look at those APIs and you can connect the way we connected from the client. In the, in the similar fashion, you can also connect from the uh, any of this from the program, any of the programming language. Make sense to you? Great. So Zookeeper is primarily used to improve performance. In a way, yes, but here the performance connotation is so high when the availability comes into play that sometimes it becomes impossible to use without using a central service. Okay, and to avoid, so it's not only performance. So to avoid the data corruption, in case there is a service, there are multiple nodes trying to write the data and all of that. In case they do not use a coordination service, they might end up with having inconsistent data. Okay, it's like saying, why do we require locking in case of threads, in threads or monitors in C? Okay, basically concurrent programming we call it. If we do not have a locking system, so exactly the way you can look at this way. So there is a guy who is there is a traffic lights at the junction, right? So traffic light do two things. One, it avoids the accident. Second, it makes the traffic run faster. All right. So it's not only improve the performance of the traffic, it also improves the performance. It also avoids the accidents. All right. Great set of questions. Now, all right. Now, the way it happens is, on one hand, there are servers. These are the servers which are maintaining their listed Zookeeper, and on other hand, there are clients. So in the beginning, clients as well as servers both connect to the Zookeeper, and Zookeeper says, okay, I have accepted your connection request. I will confirm to you in a minute. So this is a async request. And once it is done, the connection is done, the Zookeeper calls back and says, hey, now I am ready. You can ask me anything. Now here, next thing the server does is, can you create an ephemeral node for me? I am duck, I want to have an ephemeral node for me. Then another server would come up and say, hey, I am cow, can you create ephemeral node for me? At this point of time, if the clients ask that, can you give me the list of servers under this node, zookeeper replies back saying, I have two ephemeral nodes called duck and cow. Okay. Now, 5 seconds later, after some time, duck shuts down. This particular server is killed. Now, if the client comes up and says, can you give me the list of servers? It will automatically delete the ephemeral node. Zookeeper keeps on pinging the client back and figuring out, sorry, the this guy, the API underneath, will keep on pinging to the zookeeper so that the ephemeral node stays alive. The moment this this machine stops pinging, zookeeper will assume that the this machine is dead, and the ephemeral node created because of this session will be deleted, and therefore there will be no duck in that folder, and only the cow will be there. Okay, so this is how the coordination between, this is how these clients will be able to track which server to connect to. Okay, instead of they maintaining the list and pinging all these servers parallelly, zookeeper is doing the job and is acting like a shadow for the whole mechanism. So did it, does it make sense to you? All right. So try to create this scenario by yourself. Okay. Try to create a node called servers dash Kalyan, or with your own name, servers dash Amish, or servers dash Vikas, or servers dash Aruna, and then try to create these multiple node. Try to close that connection. I mean, just close your putty, close the putty, and then after, so you what you do is you open two three sessions. In one, you create duck as a ephemeral node. In another, you create a ephemeral node called cow. And in another third putty session, you basically do ls servers. Now you close one of the putty session, and then after 5 seconds, check whether that duck is there in the list or not. Okay. So that is how the coordination is done. All right. You try it by yourself. Okay. And these are few things you can also try to do. Okay, on each node, while creating the node, you have to specify the data as well. Okay, data can be any byte array. So there are many use cases of zookeeper, and because of that it is used by many services. You can use it as configuration, very reliable centralized configuration service. If you have multiple machines and you want to manage configuration data. So why we call configuration? Because configuration data is generally smaller than the actual data. And a distributed log service. And okay, so these are very many, a few of many of the use cases. All right, that completes our session on uh, zookeeper. Okay, so in the, okay, all right, any questions for me? So let's take a 10 minutes break, And then we'll discuss Scoop, Flume, and Uzi. And if time permits, we'll move on to Mohath. Otherwise, we can discuss that in the next session. Okay? All right, so should we start now? All right, so so there are these few tools which actually help you when it comes to importing the data. And importing the data from a, a, a source like database is very common phenomena. Okay. So when you have to export the data from a structured data source generally mean uh, a database which supports a driver like JDBC. Okay, basically a relational database. So when you have to copy data back and forth to and from a, a, a structured database into HDFS or HBase, or from HBase or HDFS to relational database, in those cases, scoop like tools are really, really great. Now, you might say that what's a big deal? Why couldn't you yourself write that whole mechanism? We'll just create a program which will read the data from your database and create a file into the HDFS, or write the data into HBase. It's actually not a big deal, to be honest. It's not a big deal. You can create your program. But since it is too frequently done, it's better to have a product ready for this, which can cater to the common needs. There are a couple of more interesting things which Scoop does. One, instead of copying it like a usual way, it uses MapReduce to do the job, meaning it runs the process of connecting. So what does it mean by importing data from relational database? Connecting to relational database, reading the data, and then writing that into HDFS or HBase. Now, this process, instead of running on a single machine, Scoop runs parallelly on multiple machines. That means in case some process fails, then it will run it again, as well as it will distribute the load parallelly on multiple task trackers. Okay, so that is why Scoop is a good way to import the data. All right, so you can simply SSH to any of the nodes 1, 2, 3, 4, 5, 1, 2, 3, 4, Hadoop 1, Hadoop 2, Hadoop 3, Hadoop 4, and start using Scoop right away. Okay, so this session is going to be a little more hands-on. So let's say we log in here. Ouch. Okay, so we can do SSH Hadoop 2. Is this clear? No. Okay, let me just increase the font. Yep, this is good. All right. Now, so we can simply SSH to student at Hadoop. Instead of Hadoop one, let's try some other database. Oh, let it be. Okay, so we are logging into Hadoop 1, and if you run scoop, it'll show you all the details about all the arguments. Okay, so out of this, we are going to use export. So export and import. So the way you can remember which one is export and which one is import, the export and import is with respect to HDFS. So if you want to import data into HDFS from relational database, you use import. If you want to export data from HDFS into relational database, then you use export command. All right. And when you say help import, it shows you the list of all commands. Okay. So you can see that it's fairly, I mean, quite exhaustive feature set. It provides you quite exhaustive feature set. And Scoop provides something called a connector, and which basically means that you can create a connector in case there is no connector existing, but you will never actually require to create a connector because there is connector for every database. Every database that supports JDBC is supported by Scoop. Okay, so almost every database you will always have the JDBC driver, and therefore you can use a scoop with that. So to start a process learning Scoop, let's just create a sample database. Okay, so here the sample database name is Scoop 3. Okay, all right. So we have Scoop 3 already created for you. So the way we can check MySQL minus root minus u and minus root. Okay, so here we can say this is my SQL command prompt. Okay, and using this we can basically list down all the databases, and as you also can see, Hive also is storing its database in MySQL only. And so we can say use scoop ex3 and show tables. And here we have already created a database, like select star from sales. All right. Now the important part here is this database is installed on only one machine. MySQL is only installed on Hadoop one. And all these, when I run a scoop commands, it is going to start a MapReduce process of importing data. That means the MapReduce might be mapper would be running on Hadoop 2, Hadoop 3, Hadoop 4, or maybe Hadoop 1. That means our MySQL has to accept connections from any of these servers. All right. So when you are setting up MySQL and you realize that, hey, we are going to use Scoop for importing, you need to test whether your MySQL is accessible from all the nodes in the cluster or not. Okay. So this is a common mistake which most of the people did. Okay. So most of the people who gave a demo on a virtual machine, they were pretty happy that their code is working. We are able to import data from relational database to cluster, and everything just works. But when the same code was run on the cluster on the cloud, where there were multiple machines and MySQL was installed on one of the machines, it did not run. It failed, and it failed. I mean, and then I mean, so you need to be careful. You need to test in a proper circumstances about your code. and also ensure that all the nodes are able to access the MySQL. Otherwise, all your scoop task will fail. Okay, and that's the mistake I was also making earlier, and I was wondering how come it's not running. Okay, that was the first mistake I made earlier. And you might ask that why do we require MySQL import and export? So as we have talked earlier in our normal example, where we created the list of movies, and once we will run the recommendation and will generate the recommendation, we will be exporting this recommendation data, the results of our big data analysis. That result have to be displayed to the end user, and for that to happen we might have to push this data, the results, from HDFS into our normal J2EE web server or PHP web server, Apache web server, or our CMS. And all of them use the database, and therefore you will have to export that data from HDFS or HBase onto the relational database. So that is the use case. Now we have created this table already, and in our MySQL we want to import this table into our HDFS. All right. So and here the permissioning part, as I was explaining, that it should be accessible from Hadoop 2, Hadoop 3, Hadoop 4. I have explicitly given permission here on this database. Okay, I've already created this database for the demo. You can create your own database and try it out. And this table I have already created. It's a table in the our relational database called MySQL, and then we have inserted this data into that table. Okay, all right. Now the real part that let's run the command. So what does this command do? It will basically connect to HDFS at this, okay, with this SQL URL. I'm sorry. So I'm getting a little disturbed. Yeah. So what we are doing here is we are saying scoop import means import from SQL database, and this is our JDBC URL. Okay. This is our JDBC URL. And once we and then this is the table and number of mappers. Okay, remember we can specify more mappers here. More mappers means from more number of nodes we will get request onto MySQL, and parallelly more nodes can import data into the same file. Okay, here there are no reducers, there is only mappers in case of scoop. All right, now let me just try to show you. All right. Let should I open? Yeah, should I open? I think let me just connect to any of the node. You can run the same command. It will work fine. All right. So here there will be widgets Java. I'm deleting it, and Hadoop fs minus ls. So there is widgets old, but there is no folder for widgets. Okay. And now let me just run this import command. Okay, I have provided the username and password for SQL, so it will connect to my SQL and then import the data. So it says it looks like you're importing from MySQL, and it also gives that you can use minus direct. All right, you can see that the map reduce job is running, and also on this job, you can see that zero reduces are there, only maps are there. So MR job is basically connecting to our MySQL and importing data. All right. So instead of importing from a single machine, generally the way we have been traditionally doing is write a program which connects to one database and which and also connects to another database, read from one, write to another, and game over. But here, what we are doing is we are dividing the task amongst multiple task trackers of importing the data. Okay. To make it faster, all right. Now three records have been written to HDFS. Now we can have a look quickly. Hadoop fs minus ls. So there you see this widgets folder which is created on 28th June, and you can see Hadoop ls this. So there is part M. Notice the M part. Here there are no reducer. Therefore, the mapper itself writes directly to the HDFS. Okay. Now you can have a look at this data. Okay, you can say, all right, you can basically say things like this. You can see that it has copied our data, comma separated, and put it into the database. All right. Now, let's say you wanted to import directly into a Hive table, right? Hive has tables, and you already have schema, and we want to import the data into Hive directly. So for that, you can do two steps. Either first import the data into HDFS, then create a table in Hive, and then load the data from HDFS into Hive. Okay. So for that, so the mechanism would be you create the table. Okay, you say create Hive table based on our MySQL table. So we are not providing column values here. It will figure out the column values from MySQL. So based on the table available in in MySQL, it will try to create the table in Hive. Okay. So now let me launch another terminal, and this time let me just launch it on Hadoop 3. So this is my Hadoop 2, this is my Hadoop 1. I'm just launching it for the heck of it. We could have done it on a single machine, doesn't make a difference. Okay, no matter whether you are interacting from Hadoop 1, Hadoop 2, Hadoop 3, HDFS is same for all. Okay, Hadoop FS, and okay, so I'm launching Hive. Here we have one command prompt. There is Hadoop 1, and there is Hadoop 2. This is Hadoop 3. So we are launching Hive into Hadoop 3. So we can say after loading, we can say load data from our folder. Remember, we created a folder called widgets, and from that, all right, so we have show tables. So in Hive, a table is already created. Okay, you can see describe widgets. You can see that. So this table is created based on our MySQL table. Here, this is our MySQL. Okay. Show tables. This is our MySQL. Use, what was that? Okay. Select star from widgets. So this is the table and describe widgets. So this parallel to this, it has created in Hive this table, but this table, let's see if it has some data in it. Okay. Okay. Already from the last session, there is some data. So let's just drop the data. Drop table widgets, and is it there in our, okay. So let's try to create the table. In that, we use create hive table command to create the table in the hive. All right, now you can see that. So we are in hive now. We can see show tables, show tables, and select star from widgets. Now you see no data, but table is there. Describe widgets. Yeah, it has created an empty table. Now let's load the data. Okay, what we are saying, we are loading data from widgets into our table. All right, so we did, if you see select star from widgets in Hive, we have the data, right? So we loaded into Hive in 3 steps. First, we copied data into HDFS. Then, as a second step, we created a table in Hive, and then in the third step, we loaded data from HDFS, which we imported in first step, into the table which we created in second step. All right. Now, if we had to do the same thing using a single step, we could use scoop import directly. Let's drop this table again. Okay, let's drop this table again. All right. Now, if you run the import directly, it will create the table as well as it will import the data. So what does it say? It says that the output folder already exists. Let's just delete that. Hadoop fs minus rmr. Which folder are we talking about? Yeah. Okay. Now again, you can see that it's importing using MapReduce. So as we talked about, Mapper not only gives out key value pair, can also do other magical things like connecting to databases, for example. So anything a Java code can do, a Mapper can do. All right. Now it has done. So we can say select star from widgets and it's here. So that's another way of importing into Hive in a single step. Okay. Now next is if you want to create a table directly into HBase, then you could use Scoop to import the data into HBase. Let's just exit from Hive. Now start HBase shell. Okay. So we have a customer called HBase table called customer, and we can say delete customer, and we can say delete table, disable, and then we can say drop. Yeah. So now we have deleted our old data. Now let's try to import into HBase. Let me explain to you the command what we are going to use. So it says that scoop import from this SQL database this particular table into an HBase table called customer into a column family called CF1 and connect to our SQL database using these details. So I'll just put those details together. So right. So this way this will be a little clearer to you. I'm putting backslash so that our command can spread across multiple lines. Okay. So now here we are saying import the data from my SQL, this particular table using this particular table called widgets, connecting to this particular database on running on this host, and this is my username and password. Read this table and import the data into my HBase table called customer, a column family called CF1, create the table if it doesn't exist, and then columns A1 comma B1. Okay. So it will basically pick up A1 and B1 from this table and copy that to your database while picking up while making this particular column as our row key. Okay, because in case of HBase we need to have two important things, two important part. One is row key column and other is the column family. So we had to define our column family here. All right. So this is optional, so we can remove it. And yeah, so all the columns from our SQL table will become members of this column family CF1, and new table will be created. Let us just launch. So it's running. All right, so there we are. So it has imported the data into our HBase. Let's say scan customer. Now you can see that it has imported our this data, which is select star from widgets. So this ID will become the row key, and these will become the various columns. Right? You can see that CF design date, CF1 design comment, CF1 design date, CF1 price, CF1 version, and so on for each of the IDs. Make sense to you? All right. So this way we were able to import our data from normal database to HBase. Okay. Now let's say you have to do the reverse thing. Okay. Let's say you want to copy the data from Hive into MySQL. So the process is very, very straightforward. Just that this time you'll have to create the table in MySQL manually. Okay. So let's say we create a table in Hive with sales.log name. Sorry, we create a HDFS table with sales.log name and then import it into into a table called sales. So in Hive, we have here, uh, okay, so this here I'll launch Hive, and in MySQL, we have already imported our table, right? Show tables. So it has got already a table called sales. Okay, I'll just delete from sales. Okay, so I've deleted the data from sales. I've not dropped the table. Okay, so that's MySQL, and this is Hive, and we can say show tables, and there is already a table called sales. So we want to import this sales tables data into MySQL. This data of sales, which has this table here, you can see. So we need to take this data to our MySQL, meaning exporting the data, exporting from the reference of HDFS. All right. Now the process is pretty simple. We the only point here is you'll have to create this table in MySQL manually. Scoop doesn't create the table based on Hive in MySQL. Okay. So this is a little manual process. Okay, this table you have to create manually, and then you can simply run this command called scoop export, and we have provided all the details about our database, which table to export to, and then we also provide here the directory in which our data is existing. Okay, and that's all. So we are essentially exporting data from HDFS into MySQL. Okay. All right. So it's running it. Okay, so it says exported 4 records, and let's see if they have come. Yeah. So it has imported the data. So you can see that it has imported the data, and that's all. Okay, so we were basically able to. So on one side we have MySQL. On other side we have HDFS, we have HBase, and we have Hive, right? So we were able to copy the data from MySQL to HDFS, MySQL to HBase, MySQL to Hive, and this invariably we were able to also take the data back from HDFS into MySQL. In the same way, if you do this scoop export, you can take the data from HBase to MySQL back. All right. So this demo was clear to you? Great. Great. Vikas, Amish, Ngoba, Kirti, Lingli, Ramesh, Sandhya, Basant. Great. So all are awake and all right. So these are the things we did. Okay. So yeah. All right. Now next thing is a little more different from what we have so far studied. Okay. So in a traditional sense, we whenever we talked about export tool, import tool, all we talked about was uh, how can we take some records from one place to another or do some kind of a translation or format. We can reformat the data and all of that. But here in case of big data, 90% of our problem is with respect to the data transfer. Okay. And for that matter, if when I underestimated the problem of data transport in the beginning, but when I looked at the companies like Yahoo at InMobi and even Amazon, there was a separate dedicated team whose only role was to build and maintain the tools for importing and exporting the data from one place to another. Transfer of the data was such a big deal that it required a dedicated team. Okay, so this is something very strange. I found that transport itself is a very big deal when we deal with big data, and therefore there are many evolution that have happened in this domain with respect to the transport of the data. Okay, so Scoop was a fairly obvious and simple tool, but Flume is a little different tool, but is very useful and quite interesting in itself. All right. So what exactly is Flume? Flume lets you flow the data from all your places, from many web servers, from your internal machines onto the HDFS. Flume helps you transport all of this data to the HDFS. And that is really interesting. And how does it do is it's actually a brilliant. Okay, it's very brilliant. So it does it in a very distributed and reliable fashion. Okay, it's it's basically a very distributed, reliable, and available system for efficiently collecting, aggregating, and moving large data from very different sources to a centralized data store. Okay, and that data store is generally HDFS. So what you do is it's like a pipeline formation, and just like pipeline formation, you have these connectors. And like a male female connector, we have source and sink. On one end of the wire is source, and another end of the wire is sink. Okay, if you have been using these cables these days, right? Say USB cable, on one end of the wire you have USB 2.0 connector, and on other end you have mini USB, micro USB, and all that, right? So in exactly same fashion, this Flume has been built. So you have these individual agent. You can think of each agent as a single USB cable. Okay. On one end there is on one end there is source, and other end there is sink. Okay, and you can connect these wires with each other to basically do anything you want. Okay, so as part of each agent, you have two ends to it. On one end there is source, and another end there is sink. Source decides what kind of data will it accept. Like in case of a USB wire, on one end there is USB 2.0 connector that decides what kind of sources it will feed to. Okay, sink decides where will it store the database, store the data. So basically that analogy of having these wires, connectors is good. Okay, now there is something called channel. It's actually, maybe my laptop is heating up, so I'll have to disconnect you for a second, and that might disrupt things. All right, so yeah. All right. So are you able to hear me? All right. All right. I think this thing shows that I'm still muted. This is awkward. All right. Okay, so it shows that the attendees unmute me. This is crazy. All right, so I'm hoping that all of you are able to hear me because this thing is still showing me that I'm muted. All right, so at least some of you can hear. Never mind. So yeah, great. Everybody's able to hear. All right. So the way the design is such that the design of Flume is such that you can actually do a lot of different permutations and combinations of connecting, and therefore therefore this actually helps us in a number of ways. Okay. All right. So Flume agent basically reads data from various sources, from a source, puts it in the channel, and from channel it goes into sync. Now you might be wondering that why is there a need of a channel. Now imagine this: sync is trying to write data into disk, and source is reading data from a service. Now disk takes a long time to write, therefore this data has to be kept into in a transit. The data has to be kept somewhere for the time being, and that's where the channel comes into play. This is like a temporary storage, correct? Now, if there was no channel, what would happen is when the writing is happening, reading has to be stopped, and which is not a great idea because a service like web server will continuously keep on giving the output. You cannot stop your consumer, you cannot stop an e-commerce website till the point you have stopped writing the logs, right? Therefore, a channel is very much required. And while reading the data from various sources, Flume can read from tail, tail minus f. Can anybody tell me what does tail minus f do? Anyone? What does tail minus f do? Yeah, yes, it tails the file, as in when the data is getting written into a file, it keeps on printing it. Yes. So it continuously keeps on reading it. So it reads from various kinds of sources like tail, syslog, log4j, and all that. And Flume nodes, you can arrange these nodes and connect to each other to actually support arbitrary topologies. And that's most powerful thing about Flume. And whenever you have to flow direct data in a unidirection from one place to another, Flume is probably the best solution. Okay. Now, in this example, we will we will basically try to demonstrate how we how are we going to load the data, and how are we going to run our Flume agent, which will accept the data at a particular port and then write it to HDFS. Okay, so here you can see that in Flume properties, what we do is we first define that in our agent called A1, these are the sources. Here there is only one source, but if we had multiple sources, we could put these kind of things. Okay, then we'll have we can define that these are our sink. If we had multiple sinks, we could have put this, meaning all the data that is being received from all the sources will be concatenated and put into both the sink. Okay, so all the data being received from R1 or and R2, there if there are multiple sources, that will be received and put into sink. Then we define something called channel. These are just variables. Okay, now the next step is defining what does it mean by R1. Here we are saying that our R1 is, which is our source type, is netcat, and we are binding to localhost, and we are is we will be listening to this particular port, which means when our agent runs, it will attach itself to this particular port and will wait for data to come. Okay, so our web server, our various machines can write the data to this port. No matter what is the format of the data, our our agent will receive it and put it into the channel. Okay, now let's have a look at the actual one. So here we are saying our sync type is HDFS, which means whatever data gets received is saved into this particular location. We are saying s1.type, which is our sync type, is HDFS and path is this. And here we are saying Our channel is just in memory channel. It doesn't temporarily store data anywhere other than in memory. And we are defining a capacity. If the capacity goes beyond it, it will stop reading the data. All right. Now, once we are done with that, we can basically run our Flume agent. And then once we have run the Flume agent, we can start writing the data to the Flume agent and check if it is being written continuously into HDFS. So let's just, we are at Hadoop 1 and we can actually do it from Hadoop 2 as well. But let's see. So, okay, the way I have structured it is this. Here is Flume, cd Flume, and in this there is a configuration file here, and there we can simply say, okay, so we are saying in this this command we are saying Flume ng, which is next generation. This is a command prompt, not command prompt, this is a command line utility. There we are saying run the agent, and our configuration exists in this particular folder, and our configuration file, main properties file, is this one, and our agent name is A1. Okay, and rest is just the this console. Okay, now let's just this is just information about how is the error going to get reported. Okay, now it has created a channel at this port, meaning it is listening on this port. In case you're wondering, let me just show you what was there in conf file. So whatever we were showing you in the proper in the slides is written in the configuration file. Okay, so control Z in Unix sends any process to the background, and FG brings it to the foreground. Okay, that's what I did. And now we are running the this thing. We are running our agent on this particular port, so we can say telnet hadoop 1 dot nobigdata.com, and we can specify the port number. Okay, telnet hadoop 1 dot nobigdata.com. Telnet is just like SSH, and just that it is not very secure. So it says, okay, okay. Since the way we have started our service is only on the local host, if we had mentioned Hadoop one in here, if we mentioned Hadoop one in here, that means it will be able to connect from the outside. Since we have only mentioned local host, while binding, it will not accept the connections from anywhere, except for this local machine. So we'll have to connect to the Hadoop one itself. All right. Now in the browser, we are going to open our, okay. So we have to open Hue so that we can. So where will our data go? Our data will go into this particular folder on Flume inside HDFS as giri slash Flume slash web data. Okay. So our agent is running, it's waiting for data to be written to it. And in the meantime, let's just clean up this folder. We say, so it is sgiri/flume. Okay, so there is this web data folder. I can delete all of this. This is okay, great. Now, so this is empty right now. As we create more and more data here, so we are connecting to telnet localhost, and on this particular port, so now we are connected to our Flume agent. So anything we write here or any other process who is writing to to our Flume agent is getting written into HDFS. Okay, so that's what we are doing. And you can see here, if I refresh it, you will see this data. So it is being continuously written into HDFS. So you can see FS, DFS, whatever I was typing, it is coming here. All right, in the binary format. And the format of this data is something called bytes writable. Okay, so it's basically writing the data into as bytes into HDFS. Make sense to you as a binary file? So while on one end the agent is listening to our input, okay, and on other end the agent is writing into HDFS. All right, make sense to all of you? Great. So we will talk about Uzi in the next session. In the meantime, you should try all of these things, including import using Scoop and import using Flume. All of these things you should try by yourself. Only then you will get the real confidence into these technologies. All right. So work on the H-based problem and come up with a design, and also finish H-based questions, the objective questions. Okay, and also you can take the quiz as many times as you wish. Okay, it's not mandatory that you just finish in one go and then, so we generally consider your best result, although we have the complete record of your of the past records. Okay, so feel free to attempt the questions as many times as you wish. Okay, overall objective of these sessions and everything is that you should get a fair amount of idea into all of these technologies. All right, great. So okay, so our next session, next course is starting from July 11 after this course finishes, and so you can refer your friends for the course. All right, okay, so thank you very much. And if there are any questions, just drop an email at Hadoop at No Big Data. Okay. Thank you, Dia. Have a great week ahead. And I hope that you're enjoying the sessions. All right. All right. Thank you, everyone. Have a great week ahead. Bye bye.